Hi everyone, welcome back to my channel. In the last video we have seen the FGG and theoretically and also in a Python how to build, how to let's see, write the architecture of VGG16. And as you have seen in this, in the, in the last video, I have I have shown you these steps. Now we would like, as I said in last video, this only the structure, and we would like to use this structure to train our model and see, let's see, building a model for instance, for image classification and see how it's working. So let's just start and continue with this stuff. So for this, let's say I have added, this is our structure. Now I need what I need a data and data loader. So let's say this is to load the data and transformer. So transformer this after loading the images, we need to transform the images. So all pixels, let's see, have to be normalized and considered as a sensors. And the next one is using the loss function, and for this we will use the cross entropy because we have let's see multi classes. So if you have only binary class, you can use entropy or softmax for the you can use cross entropy or yeah. And we need also optimizer. So this optimizer, it's working in a back propagation. So this after calculating the error, see how is this working, the training? It's reading, extracting the features of all these images. Now try to predict with this classifier here. And finally, let's see, is it classified correctly or not? If not, we need to optimize the model, the network. So we're using optimizer. During the back propagation, we will use Adam optimizer, adaptive moment. And also we need a for loop, just because it, I want to make it super easy for you to understand it. Load for loop for the number of ebooks. So how many let's see iterations we would like to go through these images, the whole images. This is the for loop, and the second loop is loading loop. This way I write it as a code, don't worry. Loop 2, reading the images in batch. So this batch size, it means you have, let's say, a big data set, and it's not easy to load all of these in in one time, let's see, in a memory. So that's why we need to use a batch. So every time we will read, let's see, 2 or 3 images or 10, depends on your GPU's capacity, right? And this is the main, let's see, the main important aspects. And let me just try now to load, to import the transformer and data. Let's see, we start with the data loader. So from torch, I have seen the torch before, yeah. From the torch dot utilities dot data import data loader. And the second one we need the This is for data loader. Yeah, I should start with the dataset, but yeah, it is fine. And also we need the this is to read the data and also loading the data indeed. And I need, let's see, a transformer. So from torch vision import transformers. This will as I said, this will transform the image from raw images to the format that will be readable by the model. And also I need to add the optimizer. Let's see, from torch import optimizer, and we will define which optimizer we need. So let's define now the transformer. So I'm just having the data here. It's nothing. It's just only C1. Let's see, for instance, class 1, class 2, class 3, class 4. This, for instance, for the training. And for the testing, we will also have the C. So this is only a dummy example. That's nothing. So if you see here, it's the same images in each class. But just to show you how thing is working. So as you can see, for instance, I have the folder here, and I have 3 different folders. If I need, for instance, if I have 3 classes, and the dog folder, let's see, dogs folder will have many images. I mean, only the dogs, and the cat will have only the cat's images, also the birds, etc. So let's add the transformer because it's important. Transformer. So transform. I have say I showed you the trans. This is enough. Transformers dot compose, and you have see this, right? And also this. So in the first step, we need to resize the images. So transforms dot resize, and we have the image size. Let's see, like this, and also image size. This is considered as parameter, but we should define it here. So let's see. Because if you would like to change it maybe later. So this is the image size, and we have also, this is the transformer. Yes, so we need it as a size. So we need as a size like this. Now we need to transforms to tensor. So we need to convert this to tensor, and we might also need to normalize the images. So normalizing the images to make it as the ImageNet. So transforms dot normalize, and we have mean, it's equal, let me just see what is ImageNet normalize, yeah, normalize. Yeah, I think this one here. I'm quite sure this is what we are looking for. Okay, let's see what's going on. So this one here, this is a transformer. Once we read the image, we will try to resize it, convert it to a vector, and normalize it. Make it so, for instance, the the normalize after normalization, we will minus the mean divided by the standard deviation each channel, and we will have the values between maybe -1 and 1. And now we need to load the data set. Let's see, data set. For the data set, we have train data. It's equal data sets. We have imported over. Okay, we have to import it as well. So data sets dot image folder. Yes, image folder. We need root equal. Let me just see this. Tree directory. Let's see like this. I have the train directory. I'm sorry, maybe the time is moving. I'm not quite sure, but let me just do some stuff, and I will try to stop and also now transform. It's equal to trans. This is for the training dataset, and you have to do it for the dataset or the dataset for the validation also. Valid data. It's equal the same, I will see, but this has to be different directory. But for me, for now, I will just keep it as it is. So because and now I need the training. This is the training data. Now I need train loader. Train loader is equal data loader, and we need to have data set is equal to train data batch size. It's, let's see, optimal to define the batch size as well here. So let's see, each time we need to load 4 images, maybe because my GPU has just let's see, not that optimal. And what's this batch size? I will batch size, and there's also one option, as you can see here. This is the options that you would like to see. So I mean to use pin memory, false, drop, timeout, number of workers, but number of workers, it's not working in a not working well in Windows. It's better to try it in let's see, in a Linux. And yeah, this one here, shuffle data. It's, let me make it true. So what is this does the shuffle? So every time we load the data, and maybe we and at each ebook we will have a different images in different ebook. So it's better to have it like this. But for the validation, let's see. I will just have copy this and valid. And as I said, this we need to change it to valid valid data. Why it's not defined? Okay, valid. And for the validation, we don't need to shuffle this, because we need to have the result for each time the same. I mean the same data set, the same image. Because if you shuffle the data, you will get different results. We need to control the algorithm and see how is this working. Now we have already, let's see, creating this model. Let's just put it here. I think we can add it to two device, right? Two device. Yeah, what is the device here? It's called it might be a CPU or GPU in your stuff, but you can see here. Check if you have. Let's see, for instance, device is equal torch dot device torch dot device CUDA. If it's CUDA, if torch dot yes, torch dot CUDA. We need to check if it's available. Yeah, is available. So use torch if available. I mean CUDA if it's available. Else CPU. Now we need to remove this and see device. So by the way, I have shown you maybe in the all the videos, I mean in the same playlist, how to install the PyTorch, and you can see here, for instance, I have Torch version I mean CUDA 11, and the source is from Torch, and the Torch is here. Now, even if you don't have a CUDA, I mean a GPU, you will have installed the CPU by default. So this installation in a TOML file with Biotree will save you much time. So let's be back here. I don't know how many classes do we need. Let's keep the default. How many? What was the default here? 5, maybe. Yeah, no, we need to have it for 4 classes. I mean, because I have 4 classes here, so should be like number of classes should be 4, just to be in a safe side. Now we need the loss and optimizer. Loss and optimizer. So loss is equal in entropy loss, and the optimizer, it's equal to opti. Now we need to define which optimizer. So I have also described this. What is the Adam? What is the sophisticated gradient descent? What is the ADA group, and many others. So please have a look in my. I will add the link. So you'll have add them model dot parameters, taking the updating the model parameters, and we have the learning rate. We also need to define the learning rate as a parameter. Let's see, parameters should be here. learning rate. I don't know, maybe this, or just, and we have it here. Now we need a training. Let's say we also need a number of iterations. Ebooks, number of ebooks. See, 10 or 100, depends on your, as I said, in the your capacity. So let's say for ebook and range ebooks. So this will start from, because I have 10, it will start from 0 to 9. Now I have model. Now because I have to train the model, I have to add this train. Let's see, running. We need to see the loss. Running. Let's see, loss is equal 0 in the beginning, right? We need to have also this correct classified as well 0 and total is 0. So we need also now another for the images labels, and we will get this from train loader. So images, we need to put this in a device, images dot to let me just check this device. Yeah, sometimes we need to put it in some, if maybe you forgot just only to have the device. So what we need to get the model device itself and put it here. But we already have this device, the image device, and we also need the labels. Labels to the device, and how to call model images. So we will try now to predict the images, and we see the output somehow here. So now we need to calculate the loss. Loss is equal, I have put it here. Let's see, we need to add, because it's the same name, criteria. We will have the outs, then the labels. This will calculate the loss, the difference. Let's see, and we have the optimizer dot 0 grad. So you can see set all gradient optimize 0 to 0. So this is in the beginning, it will just put it as in the 0. Now we have loss dot back. We have loss, yes, dot backward, I think backward. It's not showing any. This is the criteria. We have to find it here, of course. Now we have the out, the labels, optimizer, and now we need to calculate to update the network with this one here. But dot creatures dot backward. No, something wrong. But let me just do it loss. Just because this is calculating the loss, then we need to update backward. I will check this later. And after calculating, we need to optimize the optimize the network. Dot step. Let me just check this one. Indeed, I have checked this back and it's not giving any issue. Now let's see. Now we need to calculate, so sum up the running loss plus equal loss dot items. So we have now calculating the loss. So you could also add here if we need somehow another variable here. So we need just to print the ebook and also the loss function. Let's have a look here. By iteration is 0 to be iteration equal and a plus equal 1. So we see now we see if iteration, the mode of iteration is if it's, let's see, 99, or let's say 10. Is equal 0, then we need to print something. Print what ebook plus 1, because it is start from with 0, so we need just to add 1. Then we also out of, let's see, ebooks. ebooks and loss is running loss. Yeah, like this. Okay, because it takes time, I will just stop this and complete the stuff. And you can see here I have the number of ebooks, the images, and I will try. This is the by the way, the weights will be updated based on the batch size. So you can see here, I will try to load the images. For each batch size, the network will be updated. Now, after finishing, let's see, the training, the model will be saved somewhere else as you want. And now try to validate. Let's see, here's the testing data. So for the testing data, I have just loaded this, and of course we need, let's see, valid. No, of course we need another one test. We need a loader test, but for now let's use the training model loader, and we will have predicting the model. As you can see here, this is without updating any network, any weights. So with this line, you will save much time because it's only now it's a prediction, or let's see, inference. So no need to update the networks. And this, it will try to classify these images and taking the highest label, the highest value, let's see. And here we will see if it's corrected or not, and we'll calculate the, let's see, the accuracy here. I think that's it for today, and if you understand the previous one and this one, of course you'll be able to let's see, to do it yourself. Thanks for watching and see you next time.